Okay, the session is being recorded now. We are looking at a new topic this week, as you all know. We are looking at loops. One thing I did not really say in the lecture notes is to solve any problem that can be solved using a computer. That is, to write a program to solve a problem. In general, you need three types of constructs. So let me go over that here. Let me go ahead and explain a little bit. So not sure why this isn't working. All right, to solve any problem using a computer, of course, you write programs, right? So when you write a program, it has a number of statements, like your Python program, a number of lines of code here. When you write one line after the other, like this, A equals 1, B equals 2, C equals A plus B, and then D equals input and maybe some prompt here, etc., etc. You have a number of lines of code. This is the first line, this is the second line, third line, fourth line. And if you write code like this line gets executed first, then this line, then this line, then this line. And usually these statements are related in some way. For example, I am using A and B to compute C, right? So typically there will be some relationships. But of course, these two don't have any relationship at all. A equals 1, B equals 2. But what is fundamental about this sequence of lines is that they are executed in the order they are placed in the program. This is called sequencing. So this is the first thing that we learned in our programming topics. Sequencing is a bunch of lines. The physical order is also the order in which they get executed. So this is one way of introducing statements into your program. A second way that we saw in the last 2 weeks was selections, right? The second thing was selections. We had if, and then some condition here. At the end of the condition, we put a colon, and then we put a bunch of statements here. We wrote elif or else, etc. We put conditions here, and we had statements here, and we might have put else, we could have put else, we could put statements associated with these. So these are called selections. Now, not all statements here would get executed. If the condition is true, these statements will get executed. Otherwise, it will check this condition, and then these statements will get executed. Otherwise, these statements will get executed. So now we are conditionally executing statements. So the physical order is not quite what gets executed. It is selecting certain blocks of code. I think in the lecture we introduced in the video, we talked about blocks. Block is nothing but a sequence of statements. So this is the second thing that we learned. And this week, we are looking at loops. That is the third thing, loops. And in loops, we studied the while loop. The while loop has while condition. We put a colon just like we put a colon at the end of an if condition. And then we put a bunch of statements here. So there is a block of statements here. While the condition is true, this block will get executed. So once Python hits the while, it will evaluate the condition. So it is a pre-test before entering the loop. Prior to entering the loop, it conducts a test. If the condition is true, this block of statements is executed. Then it will check this condition again, and this block will get executed if the condition is true. It will keep doing this until this condition becomes false. That is the third thing that we just introduced into the course. So we have three types of programming constructs. So let's review them again. The first was sequencing. The second one is selection. The third one is looping. To solve any problem that can be solved on a computer, you need these three constructs in general. Not all problems require these, but in general, you need these. If you don't have one of these abilities, you will not be able to solve a whole class of problems. So to solve any problem, in general, you need sequencing, selection, and loops. And you need nothing else. Actually, there is a theorem that says that. Any problem that can be solved through writing a program can be solved if and only if we have sequencing, selections, and loops. So in general, I'm very loosely writing this. In general, any problem, excuse me. Let me erase all this stuff. In general, any problem solvable by writing a program can be solved using sequencing, loops, and selections. You need nothing more. But of course, if you add more constructs, if you're in computer science, you will learn things called data structures. Most of you will also learn things like arrays and other things in future classes. We will actually see things called lists, dictionaries, etc., etc. They are all constructs that are there to make things a little more convenient They are not essential, but they are very convenient. But the logic can be expressed using sequencing, selection, and loops. So that is one thing I forgot to say in my slides or in the video. Okay, and let me stop sharing this. Yeah, the other thing I wanted to emphasize was regarding something in the slides. Let me open that. Let me show you the slides here. Just going over the big points. You have seen all these slides. While condition, this is the type of loop we are looking at this week. You always write while, and then you write a condition which you have seen in connection with if statements, things like A less than B and C greater than D kind of stuff. And then we can put any statements, any bunch of statements inside the while. This stuff that I have highlighted in green is called the loop header. This is called the loop body. Each, each execution of the loop body is called an iteration. So when the while is hit, Python evaluates this condition, and if it is true, it will execute this block once. Whatever is in this block will be carried out. All those actions will be carried out. It could have if statements, it could have sequences, it could have loops inside. And once the block is completed, Python evaluates the condition again, and if it is true, it will iterate again, and it will keep iterating until the condition becomes false. And when you write your programs, notice a common error. When you have a condition like this, while number is less than 25, any variable that is involved here should have been given a value prior to hitting this while. So this is wrong because number doesn't have a value. Whereas here, number is given a value, so it makes sense for Python to evaluate this. Otherwise, Python will simply crash here because this number is not having a value. Whereas here, number is given a value, it is able to check whether number is less than 25. The other thing is, although this is not a fatal error, usually one of the variables involved in the loop header should be changed. It is not always the case. It should usually be changed within the loop. So here, number less than 25, unless you change the value of number, this loop will not stop iterating. If it iterates once, it will iterate all the time. This one, the first one here, because number never gets changed. So it is usually a bug if you don't change at least one of the variables that are in the loop header. So that is a couple of things I wanted to emphasize. The other thing is in many of these programs, you will see code like this. You do some action just prior to hitting a while loop, and then that action gets repeated at the end of the iteration. You should try to memorize these approaches, because you are going to see this again and again and again. Oh, I mean, so many times in your programming career, it is useful to commit to memory some of these patterns. That will help you write your solution more quickly, all right? And this also shows you how to accumulate stuff. Like, I want to read a bunch of numbers and add them up. So you are setting total to 0 and then adding to the total whatever value that I have in current. Look at the structure here, totally set to 0, because if you are adding up a sequence of numbers, you should initially have a total of 0. And then you keep accumulating the different numbers into total. Total is updated with the new value in current. And if you don't change current, of course, this loop will never end. So current is read in here. And look at these two things. Right, this line and this line, they are repeating, right? So that is essentially what I wanted to do regarding the lecture slides. Wanted to highlight these things. Do you have any questions? Okay.
Sorry.
Yeah.
Can we have more examples done by you for the problems that we have, like the assignment that we have for tomorrow?
Okay, do you have any specific questions about the assignment before we talk about, I mean, before we worry about what kind of examples are you looking for?
So the examples that you give in class are pretty easy, but the assignments and the labs are more harder. So we want to have some in the middle maybe done from you, so we can see how you do, how you work, and we can do it like that.
Okay. Let me say a little bit about the assignment that is due tomorrow.
Okay, thank you.
Okay, give me a second. Let me stop this share. And I had given some guidance in a video. Did you take a look at that?
Yes.
Okay. Was that helpful?
For the first part and the second, yes, but when it was for numbers from the 20 to 99, it was there. It was difficult for me.
Okay. I don't know what is getting shared now. Let me try this again. Yeah, let's take a look at a number like 35, a number like 30, 15, and 6. Let's look at these four numbers. They cover a wide range. And in fact, I don't think you need anything more than these to cover. The best way to develop the solution is to simply see if you can print for 1 through 9. This should be fairly straightforward from the example that we had in the lecture last week. We had code like if
yes, for the grades.
Right, exactly.
Grades, yeah.
So there is absolutely no problem doing this part, right?
Yeah, even the second part for the teens, for the tricky teens, yeah.
Yeah, right. So for the 10s and 10, 11, 12, 13 through 19, you can definitely check if the value is equal to 10, then you print 10. If it is equal to 20,
yes.
you print it, right?
Yes.
So the real difficulty is actually not here, but it is with, I mean, we are reducing the difficulty. We have taken care of like 20 of the 99 numbers, right? We are now
Yes.
to worry about the big thing. So if you get a number like 35, what do you do? So if you get 35, you should obviously print 30, correct?
Yes.
And then you should print 5.
Yes.
Obviously, the code to print 1 through 9 will print 5, correct? That can be used in principle to print the
Yes.
5 of the 35, right?
Yes.
Okay. So if you get the number 35, the thing is to split it into 2 parts. Find out how many tens there is.
Yeah, but it prints in different rows. 30 and 5 are printed in different rows when I do it like that.
Okay, okay, that is a problem. That I did not go over. That's a very that is a Python. There is a Python trick for that. If you write print 30, normally if you do it like this, it will print 30. And
Yeah, and
if you print 5,
it would print 5, 30,
yeah,
and then 5. Yep.
then you will get 30 on one line
And
and
5 on the
5
other.
on the next line.
Yes.
Okay. If you print like this, I will be fine with it. I'm not, because I didn't go over this, but I will tell you how to fix it. I'm not
Okay.
going to penalize you if you print like this, okay?
Okay,
But,
thank you.
yeah, but I will tell you how to take care of it. It's a very simple thing.
So if it's okay, if I can tell, I found something, but it first worked and then not for the end
Yeah, you can,
equals. And
what you do is you write here end,
yeah.
and then you put equals, and then you can put whatever you want here, a string, and let me explain what happens.
Yeah, but at first it works, and then it doesn't work anymore. It prints only 30. Yes, because I did it like this.
Yeah, if you print like this, it will print 30, then it will not skip to the next line. Instead, it will print whatever is written here. So if you put the 2 double quotes, excuse me.
It's okay.
If you put the 2 double quotes one after the other, it is empty. So it will print nothing here, okay?
Yes.
And then if you print 5, the 5 will come right next to 30.
Yes.
So that will take care of putting these two in one line. But let me emphasize, since I did not go over this, I am not going to worry about it being printed in 2 different lines. But it is, we will look at this in more detail next week when we are looking at for loops. But you can try this. It should work without any.
Yeah, it worked at first, and then it didn't work anymore. So I'm trying to find the bug why it doesn't work anymore.
Okay. Yeah, that's a different matter altogether. Yeah. So you need to, when you get a number like number that is more than 20, more than
20.
Yeah, more than 19, you should figure out how many tens there are. That you can do using simple arithmetic, and then you can print 30, 20, 30, 40, 50, etc., and then use the code for printing 1 through 9. And let me say something else. I mean, in general about programming assignments, not only in this course, but in every course, in every real life programming situations. Let me say a couple of, let me just emphasize one thing. You will always get a new problem, okay? It is, that is something that is unique, or maybe not unique, but at least that is very true of computer science or programming. You will get a problem and then you don't know how to do some part of it. That is for you to figure out, using principles that you have already learned. So no matter how many examples you see, there will be a problem that you find difficult because none of these examples will cover that. That requires some kind of a thought process. And then you have to think and think and think, and then finally you will get the solution usually. And sometimes it may happen while you are in the shower. The trick to getting those answers is to start looking at the problems early, not wait until the last minute, because that is unlikely to be successful. It is not like putting nuts and bolts together. You know, you can't say that it is going to take a certain number of hours.
No, no, it's the thing from Saturday. I'm trying to do the assignment.
Yeah, I know. I know it is not an easy thing. You should usually start, if you get 1 week, it requires 1 week. You know, usually that is the case. And mm, I have been teaching for many years, and students always say, tell me how to do this particular step. Then I say, that is not uh, what I am supposed to be doing. That thinking has to come from the person who gets the assignment, because that is the thing you learn, you know, that computational thinking, that thinking process, you know, it is not easy. And it never is easy. I mean, as you get more and more experience, you will get harder and harder problems to solve, and it continues to be difficult. But the only thing is you have a little more confidence that you have attempted hard problems in the past and you have succeeded, and you are able to use that confidence. You get that ability to see the patterns in the problems and use those use that experience. It is not that the problems are going to get easier or that you are not going to find them difficult, but it is the confidence that comes by independently solving a large number of problems. So I would encourage you to try as many problems as you can. This is, it is impossible for me to give you more than these many assignments, you know, and solve more than these many problems in class. That is not practical. We only have so many hours. But never put this to rest. Don't, I mean, you may have a gap between this course and the next course you take. And if you have more than a few weeks, you're going to find that all this has rusted. So if you are taking ICS 141, do it next semester, not in the summer. That would be a mistake, huge mistake if you do it, because then you will lose that momentum. Okay.
I wanted to, so you can do more problems, so we can see how you do, so we can learn from you.
Yeah, that is what I was saying. You know, I had that. There is only so much I can put out there. I mean, I have put a few problems. I have solved a few problems and put them up in the examples, but and I have shown you how to attack this problem by building, right?
Yes. Okay.
Yeah. I can try and put more stuff, but again, you will see some other problem that has no relationship to what you have seen, you know. Yeah. That requires, again, more thinking, more independent thinking. But I will try my best to give you more examples. I may not be able to put out anything tomorrow, but I will try to put more solutions for.
No, I want the D2L, and I saw the examples, but they were repeated 1 to 5. It was the same for 4 categories. So I went to the examples, and they were the same.
They were the same? You
yeah,
mean?
1 to 5 were the same for the 4 categories.
You mean the examples on the D2L site?
Yes,
under which one? Under loops or under?
No, for input, output.
They are all
Sorry.
repeated?
Yeah, sorry, I can go there and check it now.
Okay. Yeah, yeah, I don't know. I mean, I'll have to kind of see what I have
So,
done. I thought they were
yeah.
all different, but
No,
maybe.
input, output, more complicated expressions, list, strings, dictionaries. All these examples are the same. Example one is the same at all of them. Example two is
Okay.
the same
I'll
at
take
all
a,
of
I'll
them.
take a look. I will take a look. Okay.
Okay, thank
Yeah,
you.
and I will let you know. I'll let the whole class know what. If there is anything duplicated, I will correct the situation. Yeah.
Okay, thank you.
Yeah, thanks for pointing it out, but I will check. I mean, I never thought that they were the same.
Yeah, I know. For that, I said
Yeah, it is
thank you.
possible. It is possible. Yes. Any other questions? Yeah, well, it is important to start assignments early. And the other thing is you have to watch you have to look at all the PowerPoint presentations I give. I watch the videos. They may not be commercial quality videos, I know, but I can't do that, you know. So you will have to go through those. If you don't watch them and get something out of them, it would be this course is going to be really hard and pretty much worthless because you won't learn much. Okay. Yeah. Any other questions? Okay. All right. Then let me stop recording the.